This week we are looking at common rail wiring. It's a very necessary concept to understand because it saves an enormous amount of grief when building your railroad. And I wanted to first cover basics of DCC, which we did last week, because the common rail strategies apply to DCC as well as DC. Now, a lot of people who are running DCC will choose to simply have all of their rails connected with no gaps at all. They have no reversing loops or controls of any kind that way, and they simply connect the two rails to the DCC controller. But most people want to have some basic block wiring system, even with a completely DCC railroad, because there are certain advantages to being able to individually control certain sections of track. Moreover, if you have reversing loops, then it of course is necessary. This is the track plan and electrical layout on our old club railroad, if you will, the O-scale guys at the MRS hobby shop in Salt Lake City. Now, while we never ran this railroad on DCC, I'd set it up so that we could. Moreover, because the hobby shop wanted to have a whole bunch of different power supplies connected to it so that they could demonstrate different power supplies when people came in, I'd set this up so that we could run 8 different power supplies to any of the individual blocks. And I'd also set this up so that the entire railroad had one common rail across every gauge, every railroad branch line, everything all had one rail connected together. And every power supply had one of its 2 outputs connected to that common rail. And all of the power supplies had their other output running through the various control circuits that controlled power to the railroad. This meant that I could use much cheaper and simpler switches to control the power routing, cut down the amount of wire I had to pull literally by half, and just made the whole thing so much easier to design and hook up. Now, the most important concept to understand here is that if you're going to do common rail, all of your power supplies have to be completely unique power supplies. Each one has to have its own transformer and bridge rectifier. And the outputs of your various cabs will have one side of their track voltage all tied together, and that power will be sent to one common rail. Now, we have spoken in the past about the advantage of having a bus circuit running under your entire layout. In this case, that common electrical connection to all of the power supplies would run to one of your bus lines running all the way around your entire railroad, and then drops would be sent down from the common rail to that one particular wire. But the common rail has no gaps, no insulation, no need to isolate it. It's one continuous electrical circuit all the way around the entire railroad. And all of the power routing and switching is handled by the opposing rail, which is connected to your cab controls through various control switches. And the wiring for these control switches is much, much simpler. The switches themselves can be single pole double throw switches as opposed to double throw switches, because you're only controlling one side of the circuit, the switching rail, if you will, as opposed to the common rail. There are a couple of exceptions, of course. We've talked at length about reversing loops. And the reversing loops function outside of the common rail concept. Both rails have to be isolated through a reversing loop. And there are a few other exceptions to the rule as well, but mostly it would just be reversing loops. Now, the most important concept to understand here is that when you're doing this, each cab control, each power supply has to be completely unique. It has to have its own transformer and its own rectifier in order for this to work. If you have a single power supply with two throttles, it will not work with common rail. For this reason, most dual throttle power supplies do have two complete power supplies inside. Effectively, they're two complete cab controls enclosed in one box. Some of the cheaper dual throttle controls only have one power supply inside, one transformer and one rectifier with two rheostats connected to that, and that will not work with common rail. It will short out if you tie two of the outputs together. There are even designs that simply have two rheostats that you connect to your own power supply. Here again, this is not going to work with common rail. You simply have two rheostats here that are connected to one transformer and one rectifier. If you connect the output, the track output from the two throttles together, that will work just fine until you throw the reversing switch, which will throw the whole thing into a dead short. So this will not allow for common rail. If you're going to use a system like this, you have to isolate both rails. And that means using double pole, double throw switches to route all of your power and running twice as much wire out to your tracks. So the only time that you would use a system like this is if you had, say, two completely isolated loops that weren't going to be connected together and you wanted to run two different trains on the two different loops. That would be fine. You just wouldn't want to try connecting the two loops together. Or you could have them connected, say you have a single crossover point where you can move from one loop to the other. That will work just fine provided both direction switches are in the same alignment as the train goes across the gap. Now, as I mentioned on the MRS railroad, I'd set that up so that we could run 8 different power supplies, one of which was DCC, and still everything was connected through a common rail. In this case, you can see power supplies 1 through 4, and they're all being routed through rotary switches, which are sent off to the individual cab control switches. But as you can see, the output of all the power supplies on one side are connected together to the common rail bus. We'll take a little deeper look at that in the future. For now, it's enough to understand that all of the track output voltages from every power supply are connected together on one side of the cab control, and that is sent to the common rail bus. And all of these power packs, all of these throttle controls will work just fine, perfectly normally, with one side of the track voltage tied together across all of the power supplies, provided each one has its own completely isolated transformer and rectifier. And one of those power supplies can be DCC. This is how I've got our logging railroad currently set up, because all of the logging locomotives that I have are Bachmann Spectrum, and I haven't converted those to DCC as yet. And so, as we mentioned last week, you cannot run Bachmann Spectrum locomotives on a DCC railroad until they're converted to DCC, or they will simply short the entire railroad out. So my solution to that is to be able to switch the logging railroad between a DC power supply and the DCC control system. So it's a somewhat similar system to the way I had our old club railroad set up at MRS Hobby Shop, except in this case it's a much simpler system. It simply switches between the DC power supply and the DCC power supply on the logging railroad. So just a quick look again at the MRS railroad. We've got 2 different gauges, 3 different gauges actually. Some of it dual gauge, and 2 different main lines, several different branch lines, switching areas, and all of this has common rail. One of the rails for all of this is all tied together, and all of the outputs of all of the different power supplies are all connected together and connected to that common rail. Well, I hope this has been clear. If not, watch it again. And if you still don't understand it, feel free to ask questions in the comments area, and I will try to get back to you on this. But I hope it makes sense. If you are not a subscriber to the channel, please subscribe. And if you liked what we did here, please click the like button. The easy way to become a subscriber, if you're not already a subscriber, is to click on the upcoming blue button. Zoink, right there, the blue button. Well, we're not sure how you found this video on the internet. We hope you didn't find it boring, and Karen and I will see you here on Sunday because we have something very important to address.